Moving on through the Module 3 class notes, we now come to addition and subtraction of rational expressions. And we have to remember how to add or subtract fractions generally. And we talked a little bit about this in Module R as well, but it's not a bad idea to go back and review or ask whatever questions you have. Please bring those to me or to the tutors in the virtual tutoring lab. We'll be happy to help. But for the purposes of this video, I'll suffice it to have a reminder here that to add or subtract fractions, you need a least common denominator, LCD. And with these rational expressions, I've got one denominator of y minus 2, one denominator of y plus 1. My LCD will simply be the product of those two, y minus 2 times y plus 1. So that now I can take my original fractions, and the process of adding fractions is change each fraction to one with the LCD by multiplying top and bottom by whatever that fraction is missing. Let's see what that looks like here. In the first fraction, I've got y plus 3 over y minus 2. I'm going to multiply by the missing LCD factor of y plus 1 in the numerator and y plus 1 in the denominator. Whatever you do to the top, you have to do to the bottom. Keep things balanced. Same thing on the second fraction. Second fraction is y minus 3 over y plus 1, and we need to multiply by the missing LCD factor of y minus 2, top and bottom. If you look carefully, you'll notice that I accidentally wrote y minus 1 in the denominator of each fraction for the rest of the entire problem. And then I drew a little vertical bar to make the minus sign into a plus sign. So that's why that looks weird. Anyway, let's keep moving here. In order to add fractions, we recognize now that both fractions have a common denominator, so we can add into a single fraction with that common denominator. Keep the LCD of y minus 2 times y plus 1, and I have to add the numerators. Since I'm adding the numerators, then I want to combine like terms. To combine like terms, I need to FOIL so that I can find like terms to combine. So I'm going to multiply y plus 3 times y plus 1 to get y squared plus 4y plus 3, and y minus 2 times y minus 3 to get y squared minus 5y plus 6, so that I can then add those numerators together, combine like terms to get 2y squared, 4y minus 5y is minus 1y, and plus 3 plus 6 is plus 9. Keep your common denominator of y minus 2 over y plus 1. Notice I didn't bother FOILing out the denominator of y minus 2 times y plus 1. You don't need to. In fact, it's better to leave it factored because you always want to make sure that your answer is in simplest form, meaning factor it and see if anything cancels. So it's best to leave the denominator factored, and then let's actually take a moment right now to take a look at the numerator and see, can we factor that numerator? Let's see, the AC method is 2 times 9 is 18. I'm looking for factors of 18 that add up to negative 1. 1 times 18, 2 times 9, 3 times 6. No, I'm not going to get anything that adds up to negative 1. So I'm not going to be able to factor the numerator, which is fine, which means I'm not going to be able to reduce and simplify any further, which is fine. And that means that this is already in simplest form. Let's do that again here with example 8 and an example of subtracting fractions. The process is going to be exactly the same. We're just going to subtract the numerators that we end up with instead of adding them. We still need to find an LCD, and we still have two different denominator factors, x plus 1 and 2x plus 1. So our LCD is going to be x plus 1 times 2x plus 1. We then take the first fraction, multiply top and bottom by the missing factor of 2x plus 1. Take the second fraction, multiply by the missing LCD factor of x plus 1, top and bottom. Now we've got our common denominator, and we can keep that common denominator and subtract the numerators, just like we did in the last example. To subtract the numerators, we'll FOIL out the numerators to then find like terms that can combine. In the first numerator, I've got 2x squared minus 2x plus 1x is minus x minus 1. And then the second numerator is 2x squared plus 2 plus 3x is plus 5x plus 3. Combine like terms now. 2x squared minus 2x squared, the x squared terms actually cancel. Negative x, careful, minus 5x, don't forget to distribute this minus sign. Negative x from the first numerator minus another 5x is negative 6x. And negative 1 from the first numerator minus positive 3, so minus 3 is minus 4. So I've got negative 6x minus 4 divided by x plus 1 times 2x plus 1. And again, if you can factor and cancel, do so. But no cancellations are possible in this case, so this is a perfectly good simplest form that we can use.